All right, so before the lecture even started, we created a file called Lecture R. We added our console read line at the bottom, so you'll want to catch up and do that if you're following along. So what we have been doing so far are one-dimensional arrays, which is just like a list, right? It's a list of items. But if you've ever played the game Battleship, you sunk my battleship, right? You have rows and columns. That's a two-dimensional array. Or if you've used a spreadsheet, and I know you have, that's a two-dimensional array, right? Where you have a whole bunch of rows, and you have each row has a whole bunch of columns. So you can have two or more columns of values for each row. A rectangular array, also called a matrix or a table, is one where you have the same number of columns in each row. Right, that's like a spreadsheet, and it's a 3x5 spreadsheet. Each row has five columns in it. There are also kinds of arrays that are not rectangular, where the first row has 4 columns in it, and the second row has 7 columns in it, and so on. And so that's pretty weird. I care a lot more about rectangular arrays than I do the kind where you have differing number of columns in the same row. So here's an example. This is a regular two-dimensional rectangular matrix or table. The way you access the elements, didn't mean to launch that. What is it going to do, launch? Notepad, alrighty. So, again, we start with zero-based indexing. This is row 0, row 1, row 2. But its column is 0, right? Because it's the first column. This is row 0, row 1, row 2, but its column is 1. Because this is column 0, this is column 1, and this is column 2. And this is column 3. So typically, although you could think of it in vice versa, you could think that the first number represented the number of columns and the second one the number of rows if you want to. Traditionally, the first number is considered the row number, and the second number is considered the column number. And here they show an absolutely horrible syntax for initializing a two-dimensional array full of data, which is totally fine. You can use an initializer list, but if we break it down, here's what it really looks like. Same business as we were doing before, right? We declare our array with an open curly brace and a closed curly brace, but each row in the array is another array. And that gives us the secret for how it actually treats arrays, right? We did not specify the size of the array here. We did not say that this is a 3x4 array. So if we wanted to, we could sneak in and add extra elements to the middle row. Bizarre, but we could. Don't know why we would do it, but we could. Maybe each row represents a certain number of scores and each kid took a different number of tests. So you could actually do that. Again, I like thinking in terms of rectangular arrays. So if you initialize your array, you're going to use the brace there, a brace there, and then inside them, separated by commas, each element is going to be its own mini array. So let's go and do that. Let's certainly use easier data than that, though. So I'm going to go to my file. Why not an array of strings? No, let's use an array of numbers because then we don't have to put quotes around everything, right? So int brace, comma, end brace, 2D equals open curly brace, and then I'm going to add some lines here, and we're going to stick some data in each one. So it's going to be a 3x3 array, a 3x4 array, a 2x4. Let's make it a 2x4. So the first row is going to have this data in it. 1, 3, 5, 7. I guess it doesn't take that long to type it. We could make it as many rows as we wanted to. The second one, let's put some different data in it. 4, 7, 8, 9. All separated by commas with another comma outside the curly brace. And one more row just for good luck. 5, 4, 3, 1. So we have created a 3x4 array, except I forgot my semicolon at the end right there. Anything you do with a one-dimensional array, you can do with a two-dimensional array. I want to try a for each loop and see what happens if I do this. I have a recollection that this is going to work, and if it's wrong, I'm going to delete it. You might not even want to type it until I'm sure it works. For parentheses int I, for each int I in 2D, CW tab I. That's not giving me any syntax errors. I don't know if you can tell what it did, but C# is happy to treat this two-dimensional array as a one-dimensional array if you use this syntax. I'm not sure it'll work if you use the index method of accessing it, but you see 1357, 1357, 4789, 4789, 5431. If you wanted to rip through this array, adding up all those numbers, and you didn't care about whether they were in rows and columns and stuff like that, you just wanted the total, then you don't even have to treat it with a nested loop. Normally when processing two-dimensional arrays, you have to use nested loops. The outer loop controls which row you're on, and the inner loop controls which column you're on. C#'s slightly odd there. Just for fun, let's try to access it by its index. Yeah, okay, fine. Dear C# programmers, make it so that if I start to type and the program is still running, ask if I want to close it. All right. So, trying to access it by its index. And normally I don't use I there, and normally I use value if it's a for each. I'm not going to go back and change it. So for int I equals 0, I is less than, I'm going to hard code it because I don't know how to get the number of elements yet. I'm going to leave it just like that, hard code it, because this is pure experimentation that I've never done before. Well, why are you doing it? Because I can't help myself. All right, so CW tab, and we're going to print out the 2D array at position I. Okay, now we've broken it. Good enough. Good, because I didn't know how to get the width times the height that easily anyways. Never mind. So if we call .length on this, what is it going to say? Is it going to say that its length is 12 because there's 12 elements in there? Or is it going to say that its length is 3? Let's find out. CW tab, quote, length of 2D equals, end quote, comma, 2D dot length. Now I just saw something odd as I was typing. Why is there a dot length property and also a dot get length method? Gets a 32-bit integer that represents a number of elements in the specified dimension of the system array. Okay, this is actually very, very useful. Get length is what you do if you want to get the number of elements that are in the first row. We'll do that in a minute. But for now, I'm just curious about the length. It ought to say 12. It's kind of thinking that it's a two-dimensional array. I mean a one-dimensional array, unless we start using specific methods to ask for the number of rows and the number of columns. What did I do wrong? Did I put a comma rather than a plus? Yeah. All right, and so it's saying that the length of the array is 12. Whereas in Java, if you'd asked for the length of the array, I believe it would have told you the number of rows. So, dot length gets you the total number of elements in the array. No matter whether it's a 1D array, a 2D array, a 3D array, whatever, it's just going to count them all up. In this case, 12, because it's a 3x4 array. We can also ask it just for the number of rows, or just for the number of columns. Let's ask it how many rows there are. CW tab, rows equals, end quote, plus 2D dot get length for dimension 0. And I forgot my second close parentheses. And I'll slow down in just a second. Right? It's got 3 rows. That is useful if we're going to create a nested loop so that we could print it out in, in matrix format. The 0 specifies the dimension, which in this case, 0 means number of rows. Now getting the number of columns, well, we'll get to the PowerPoint on that. I don't want to just take a wild guess and get it wrong. Let's pause for now. So to access any element in it, we will specify it by its row and by its column. How come they keep showing us how to allocate it but not how to access the elements? Well, they seem to be missing an incredibly important piece of it. We'll do it anyways. So say we want to know what position, what's the value stored here? I'm going to change it to something very unique. All right, the first value is 999. I'm going to print that out. If you think I'm answering something with no caller ID, you got another thing coming. All right, so int x equals 2D subscript So if we're going to access one of the elements, we just specify the row and the column. So at this point, x should equal 999. So if we, not C out, this isn't C++, CW tab tab, CW tab tab, x equals plus x, right? And we'll see that it equals 999. All right. We can change them the same way. We want to change that value. Well, it's zero-based indexing, so this is row 0, row 1, row 2. So we're going to use row 2, and it's in column 0, 1, 2, 3. So if we do this, 2D row 2 column 3 is equal to 888. Then when our print statement goes out, we're going to find out that the last element has been changed to 888. It used to be 1, it'll be 888 now.
Nope.
All right. So we could write loops that would fill in that array if we wanted to. We'd have to know how to get the length of the array, which is the number of rows, and then we'd have to know how to get the length of each row in order to do that. And we'll find that out from the PowerPoint. So we could go in and we could arbitrarily fill in the elements, or we could print them out as a grid. That's more interesting probably, so let's go do that. What? You gotta be kidding me that they're not going to show me how to print out the contents of a 2D array. Well, that's what Google's for. I mean, I think I remember, but I don't want to botch it, right? Print 2D array C#. So what do? You get the number of rows like that. And you get the number of columns like that. Now that doesn't handle the ragged array where row 1 has 3 elements and row 2 has 4 elements and stuff like that. So if we are worried that something hinky is going on with the number of columns, then this would not be an adequate solution. However, for us it is. So the first dimension is the number of rows and the second dimension is the number of columns. What I'm really curious about is that if we call this, but we've added extra columns to one row in particular, what it's going to return. But let's find out. We're going to go back to our code, and where we said where it says rows equals, we're going to copy that, paste it, and we're going to get cols, C-O-L-S, equals 2D get length 1. That's the second dimension. And if you had a third dimension, it would be parentheses 2 and parentheses 3 and so far for each extra dimension that you add to it. I seem to be missing a close parentheses. All right, and so it's a 3x4 array. Well, let's find out, just to satisfy my horrible curiosity, what happens if one of these guys has more elements than the other, because that's a legal definition. That's a legal array definition. So I say, is it going to give me an error? Well, what do you know? It is. That's not how you do it then. Okay, so I swear that they were giving us an example of one row with more columns than the other. If not, then great, so much the better. 1, 2, 3, 4, 5, 6. They're making each element in it its own subarray, which is slightly odd. This is for a 3-dimensional array, and we're not going to talk about 3-dimensional array. Okay, so thankfully I was wrong. Java certainly supports ragged arrays where the first row has 2 elements and the second one has 4 and the third one has 5 and stuff like that. But this one does not, and I'm happy for that. That makes processing them very easily. All we have to do is get the number of rows and the number of columns, and we can write a simple for loop to display this. So here we're going to say 1 specifies the number of columns. Well, let's get those and store those in variables just for fun. Just because to me it's easier to read them if we retrieve them beforehand rather than if we embed those expressions right in the for loop header. So int num underscore rows equals 2d dot get length parentheses 0. And int underscore num calls equals 2d dot get length parentheses 1 end parentheses semicolon. Now you just write a nested for loop. For int I equals 0, I less than num underscore rows, I plus plus. And inside here for int j equals 0, j is less than num underscore calls, j plus plus. Then we can print it out. Console write, tab, tab. But we're not going to use write line because we want to print each column, and then we're only going to do a write line when we're done printing the columns. Yeah, I'm sure that's a mistake. We'll fix that in a minute. CW tab tab right line, like that. Now in here, why are you complaining? We do have to stick something in there. Great. We were just about to. How wide should we make each element? Well, our largest piece of data is 999. And one time I had somebody ask me, how would you calculate the widest piece of data so that you would know how wide your formatting needed to be? What you would have to do is you would have to write a loop like this, and you would have to turn each one into a string, and you could find out the maximum string length, and then you would have to modify your formatting string to incorporate that into it. You'd have to build it rather than what we are about to do right now, which is to say I want each one to be 4 spaces wide. So curly brace 0, comma 4 in curly brace, comma, and then that element, 2D subscript. I didn't mean to make it I and J. I meant to make it R and C to stand for row and column. It doesn't really matter. Right, variable names are just for us. The computer does them no matter what they mean. But I really wish I'd made this R for row and C for column. If you feel like making that change, go for it. Hopefully this loop is so clear that you understand what it's doing. Right? Process row by row. Process each column in this row, or in row I. And there we go. So if you were going to calculate the total of all these, you could use a nested loop like that, or you could just treat it with a for each loop like we did here. I'm going to go add a comment up here. Use a for each loop to treat it as a 1D array. That loop displayed the entire contents of the array, all 12 elements, 1 per line. I guess I should run it before I pause it and make sure it's working for y'all, because if it's not working for me. And there we go. There's our cute little array. 999 in the first one and 888 in the last one. Just for funsies. We're going to make an array that's full of zeros. And then we're going to randomly fill it in with a couple of random pieces of data. We're not going to step through it and make a random number to put in each element. Instead, we're going to say something like, okay, I need one random number, it's 3. I need another random number, it's 2. Okay, so 3 comma 2 is equal to, you know, and then you print out your third random number.
Yeah.
Okay, so here's what I want our next thing to look like. Don't type this because this is just an example. But, oh, dadgum you. Fine. You know, I want it to show up like this. This is how we're going to create it initially. And then I want to say, okay, I'm going to generate a random number, 2 comma 3. All right, so 2 comma 3 is there, and we're going to set that to 4. And then we roll the dice again, and at position 1 comma 0. Okay, well, 1 is that one, and position 0, column 0 is that, and we could change that to another one. And so we could set random values. inside a grid, and then we could print them out. But first we have to create our array of zeros. Let's do that. Int map equals new int. Let's make it a 10 by 10. Alrighty. Let's make a function that prints out the two-dimensional array so that we don't have to keep doing it like this each time. Not a function, a method. To make it easy, we're just going to copy all this. Copy the entire for loop from beginning to end, and let's go write a method. So I've copied that, and we're going to go add a method. We're going to make it static because we're in a static context. So static void, don't know why this language likes capital letters for method names, print 2D array parentheses int square comma close square 2D. And then open brace, close brace, and then paste what we just copied. Oops, it doesn't know what num rows are. We're going to need to go and copy those two lines as well. Or we could replace them with actual calls into the array to ask it for the first one. Let's do that. Let's be good programmers. So where it says num rows, we're going to say 2D dot get length parentheses 0 because the first dimension is the number of rows. And we're going to change number of calls here inside our print method to 2D dot get length subscript 1 in subscript. So I'm going to scroll back down and call the print method, and then I can scroll back up in a minute because I want to make sure that I haven't botched it. So down here, after we create our blank array, I'm going to do print 2D array and pass our map in, like that. And it should print out 10 rows and 10 columns, like that. An interesting little exercise would be to make it that if it's got a non-zero value, print that number, but if it's got a 0 value, print a dot or leave it blank instead. All right.
Can we just go back up to the top?
Oops, even further. There we go. Now we want to assign some random values. Like if we were playing the game Battleship, if any of y'all remember. You sunk my battle? You're right, you had to guess a row in a specific column. Right, so let's generate a random X value and a random Y value and then a number to stick into that position. And we could actually put this in a loop. Right, we want to do 10 numbers or something, I don't know. Int num underscore nums. This is how many numbers we're going to make up, or num points or something, I don't know. Num points sounds a little bit more professional. And in a for loop to generate that many random numbers. For int I equals 0, I is less than num underscore points, I plus plus. Let's get a X value and a Y value, Those are going to be the row and column coordinates into the array, and then one more value to set it to. So int x equals R&D dot, we don't have a random number generator. Oh, that was for the other thing. And so if you've got a random number generator already declared in your code, great. I do not happen to have one at this point. So above where I create my blank map, which I'm going to document as create empty array size 10 by 10. Let's make our random object. Random R&D equals new random parentheses in parentheses.
Okay, so we did that.
Okay, so x equals R&D dot next parentheses in parentheses, but how big and small is our number going to be? How about between 1 and 999? So 1 comma 1000. This is between 1 and 999. Let me guess, I already have an x declared somewhere.
We do.
Okay, how about R and C?
Okay.
Int R equals, and then int C equals R&D dot next 1 and 1000. And then a value. No, wait. Our row and our column cannot be between 1 and 1000. What can they be between? They can be between 0 and the length and 0 and the width. Right, so we could put 0, comma 10, but we really should ask the array for its size. So 1 comma, no, 0, 2 zeros there. And then map dot get length parentheses 0 in parentheses semicolon. No, yeah, that's correct. 2 closing parentheses. And this next one is going to be the number of columns. So 0 comma map dot get length parentheses 1 in parentheses. Same business. But it's no longer between 1 and 99, right? It's between 0 and number of rows. And this is now between 0 and number of calls. And then a value, right? The value, since we're printing each one of these things being 4 wide, kind of just made that arbitrary decision. Why don't we make it between 1 and 999 like I was planning? So int space value equals R&D dot next parentheses 1 and 1000. And now that's going to be between 1 and 999. Let's set it. Map subscript R, comma C in subscript equals value. And I believe this is pretty similar to an assignment I gave to my advanced Java class, but I didn't actually give you this code. And let's print it out again. Wait, where'd my print statement go? There it is. So if we run it, there's our little grid. It's got some numbers in it. I'm surprised that they're all above 100. I mean, except for this little thing here. Oh, there's one. The only number that it generated that was below 100 is the number 1. That's pretty weird. And run it again. It should be different numbers each time. Ah, there's a 2-digit number. Okay. If we wanted them all to be 3-digit numbers, we would just say between 100 and 1,000. Or if we wanted them all to be 2-digit numbers, we would lower that to 100. Something like that. Okay, so we now know how to fill an array with randomly set data. This is different from going element by element, generating random numbers. It's instead like rolling 2 dice and then picking a place to insert a number based on those 2 dice. Pick a random row, a random column, and then a random value for that.
Is it supposed to be making 9 points or 10?
Since we're starting at 0, it's going to go 0 up to 9, which is 10 points.
Okay, because I'm counting, when it makes a map, I'm counting exchange 9 different values.
I'm going to add a CW tab.
And this time it's 10. Maybe I'm just crazy.
Adding point.
1, 2, 3.
It's possible for it to pick the same random numbers 2 times in a row, though. So you may actually wind up with only 9 change values, or 8 or 7. Right, because if it rolls the same numbers twice, adding point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's make this a little bit clearer. So where it says adding point, I'm going to cut that, remove that line. I'm going to do CW tab, adding value colon 0 end colon at position colon 1 end colon 2 end colon end quote comma, and let's just fill them in. Value comma R comma C. And there we go. It generated 10 values. If those are looking too weird, we could say we want our random numbers to be between, I don't know, 10 and 99. And then we'd see a whole bunch of different 2-digit numbers written. Nope. Make a liar out of it. Yeah, there they are. Right, they're all 2 digits. Okay. Whatever. All right, so actually what I'm going to ask is modify the print routine so that if the value of an element is 0, it prints a blank. all blanks, rather than a number. That's one thing we could do with it. And then just because we love averages so much, tally up the average. I would use a for each loop and just run through it, but you could use a nested loop. So that's actually tally up the total. Tally up the total. You could use a for each, but you could use a nested loop as well. And then calculate average, which is total times the length, array.length. Total divided by array.length. Why would we be multiplying? There we go. All right. So that'll be the homework. Based on this, you're just going to use the code from the lecture. So that's step A, modify the print routine so that it prints blanks. And then B, tally up the total. And then C, calculate the average. That's really enough. Okay. And so you can just use this code, use this function, modify this function so that if it detects a 0, it prints a blank rather than a number. If I wanted to go crazier, I could ask you to fill it with random numbers in a different way, but I think this is enough. I think this is enough. So let's see what the rest of the little PowerPoint is about, but I really think we've covered what we want to cover. One thing they show is how to make a three-dimensional array. And a three-dimensional array is a two-dimensional array where every element is an array. I can't imagine a four-dimensional array. My brain would break because each one of these numbers would instead be a little teeny tiny array. But you access it the same way you do a two-dimensional array, except you have 3 places, an x, y, and a z coordinate, or a row and a column and a whatever. Here they have a two-dimensional array, and they're saying that these equal the floors and the number of bedrooms. And so the rent is based on the floor and the bedrooms. So on floor 1, 1 bedroom costs $400, 2 bedrooms costs $450, and 3 bedrooms cost $510. On the second floor, apparently we charge higher and higher. When really, if I have to live on the 3rd floor, I want you to give me a discount because I don't want to walk that. But the penthouse suite, yeah, I can understand that.
I guess it just gets fancier as it goes up.
Yeah. I also like the fact that the number of bedrooms, you're going to start with 0. That's a pretty funky apartment because that's 0 bedrooms, 1 and 2, and this is floor 0, 1 and 2. So if I was going to write this program, I would have made it so that after we asked them what floor we were on, we would subtract 1 from it. So it'd be 0, 1, 2, and 3. Same for the bedrooms, right? So if they say they want 1 bedroom, we'd subtract 1 from it so that, you know.
Maybe the 4 is the efficiency.
Yeah.
Or I would insert a blank row of zeros and a blank column of zeros so that we could maintain, you know, floor 1, you know, 1 and 2 and 3 bedrooms. So, here we go. Here's the jagged array that I was talking about. The jagged array is declared using a slightly different syntax. The rectangular array is done with a square with a subscript and then a comma and an end subscript. This is done by using 2 squares, you know, 2 subscripts, whatever. And then you make each row as a brand new array with the new command rather than just simply using the initializer. I really wonder if you could simply use the initializer and not do that. But each row can be a different length. I'm not going to ask any questions or assign homework over jagged arrays. Just be aware that they can exist. They are different. the way you address them is by using two subscripts not separated by a comma but separated by the square braces. So, array issues in a GUI program. If a value changes based on user input, the array has to be stored outside the method. The reason it has to be stored outside the methods is so that all of the methods can get a hold of that array. So you make the array a member of the class and not a member of, or not a local variable as part of any method. Once the array, just like I think we had something where, maybe we didn't, where you'd add 2 to it and then add 3 to it and add 4 to it and it would get larger and larger and larger. For us to do that, we had to declare a variable outside all of the methods. Then they have a pretty neat little GUI here. Department 2 contributed 25. And each time you add that on, I guess it adds it to the tally. So you keep clicking OK. I would have changed that to an add button, and after you've run it for a while. Yeah. Again, this runs into the question of, is department really equal to row 0 or row 1? You might be subtracting 1 and adding 1 to it in order to get that to work. This is an interesting little programming problem.
Can we do that next time?
Yeah, we're not going to do that this time. In fact, I think we're not going to do that at all. But it would be worth doing another GUI program. But I'm thinking not this time. Oh, here it is. The OK button grabs the department and it grabs the contribution. But here's what I was talking about, so that you could say department 1, they're removing 1 from it, so that refers to row 0. That's not a two-dimensional array, though. I'm not getting why. It's just a 1D array. All right, so we were done talking with 2D arrays by the time we got to that picture. We're back to a one-dimensional array, where that's element 0 in the array, that's element 1 in the array, that's element 2, and that's element 3. So an array, it's a list of data items. It's a series is what I would call it, because a list is usually a separate data type in these languages. All data items have the same type and the same name. That's a strange way to put it. I've commented on that before. Every data element in here is an int, because that's how we declared our map. And every data element has the name map. That's its name, and then we access it by its subscripts, by its index values. The power of arrays, I like that. It sounds like, Castle Grayskull, becomes apparent when you begin to use subscripts. The power of arrays becomes apparent. Right? That's the only way to use arrays, is when you use subscripts. And so the subscript you use has to be in the range of 0 to n, where n is equal to length minus 1. Just like in any other language, you're not allowed to access past the end of the array. And it's 0-based indexing, so the first element is 0, and the last one is length minus 1. So a for each statement will cycle through an array without using subscripts. We did that here. We had a for each loop. When you use for each, you specify the array name there and the temporary value there, and you print it out, and there's no subscripts involved. So for eaches are nice. I may have called them value-based loops in another programming class, like fundamentals of programming. For each is nice because it steps through it without any indices. Otherwise, you have to use indexes to get the value out, and you wind up writing something like for I is equal to 0, I is less than array.length, I++, and then you can get a hold of them by their index instead. You can create parallel arrays to more easily perform a range match. Don't care about that. Binary search will let you search an array for a requested value, but it has to be sorted. So conveniently, they gave us a sort method. I wonder what in the world happens if you try to sort a two-dimensional array. Wonder what it would do. Let's find out. And then we'll probably hit undo immediately because it won't work. But if we went down here to maps, before we printed it out, gosh, I've forgotten how to use the sort method already. Let's go look. Okay. Okay. Let's see if array.sort will accept a two-dimensional array. Array, capital A, dot sort, map. Well, it did, lo and behold. And so what's it going to look like when we print it out?
Yes.
Okay, good. Anyways, okay, it really didn't work. I'm not surprised. You might be able to sort each row in it if you were using a ragged array. Oh, let's delete that since that failed. I don't want to leave that in my code. Reverse, whoops, just reverses the items. So if you sorted them, they would wind up from lowest to highest, and then you call dot reverse so that you can get highest to lowest, like in the orcs versus elves assignment. Multi-dimensional arrays, you need multiple subscripts. There are two-dimensional arrays. If you use two-dimensional, or, you know, if you use, I would add an entirely new bullet point, which said rectangular arrays, you access like this, x comma y. Jagged arrays, you access like that. It's a weird distinction. Java does not differentiate between array access using those two things. They're all done via the same syntax. Alrighty, I think we've gone far enough. I need to publish a chapter 6 quiz. I need to look at it again to make sure it's not corrupted like the other ones were. So I will get that done this evening or tomorrow so that people can take the chapter 6 quiz. And so I hope people have been thinking about the projects. I did post additional details about 2 of them. Doesn't mean I want you to do those. I mean, you're totally free to do them, but you can also do something else. So under, I think it was modules, or on the announcements, I think I linked to them. Right, PyFighter's got a really long spec, but you could come up with your own game that you wanted to instead, where you just have 2 things, and then they have an armor rating and an attack rating, and you figure out how you want to handle that. This just wound up being really long because people kept wanting more and more examples of how I imagined it to work. It's a kind of a neat project, though. You might enjoy it, but you may have already done it in another class. I would let you do it again if you've done it in another class. And then the other one that I gave a lot of details on is Caesar Cipher. So what is Caesar Cipher? A Caesar Cipher is where you take the message and, like, if the message was Fred, you just shift each letter a certain amount. So like F plus 1 is a G, and R plus 1 is an S, and E plus 1 is an F, and then a D plus 1 is an E. So that's shifted plus 1. And then later, when you want to decrypt it, you type that in with a -1 shift, and it turns it back into Fred, because G minus 1 is F, and S minus 1 is R, and, you know, F minus 1 is E, and E minus 1 is D. So that's a Caesar cipher. The more complex Caesar cipher in here rotates the values. Not rotates, it increases the values. So if you had the word Fred, you would increase F by 1, it would become G. R would increase by 2, RST. E would increase by 3, EFG. And D would increase by 4, H. Hope I got that right? So each letter increases by 1 more. That would be harder for somebody to crack. Caesar cipher, yeah, it's pretty easy to figure out if that's what they've used. All you have to do is rotate every letter through, you know, all the possible values of it, and then, you know, pretty soon you'd see the English text pop up really quickly. But this modification would not show up as easy with that kind of program. On the other hand, if you're trying to hide something from the government, I'm sure the FBI and the NSA and whatever could figure that out in like 0.01 nanoseconds. So it's not really secure. It's just something to think about. And I know that the cryptography class here talks about Caesar's cipher, so that's why you might want to implement it. I believe that what Ken says is that if you can write a program that implements Caesar's cipher, you can use it on his exam. Otherwise, you've got to do it by hand. And so, hey, if you know how to do it, and then you can implement it in Python for his class, so much the better. So the specs for that, just go through that. Goes through an explanation, fairly lengthy explanation. The little video that I did, 2 minutes that I talked about it probably is a better explanation than this, but it's pretty thorough. And of course there's a blank page. I should put this page intentionally left blank like it was an IBM manual. Then the thing is that you don't always start from 1, right? You ask the user how many they want to shift. Want to shift 3, then it turns. Now the classical Caesar cipher, you just leave spaces alone, because the Romans had no idea that you might have multiple punctuations and you could cycle through a space to become a period and a question mark or whatever, because they weren't coding these things on computers. So they just left their phrases broken up by spaces. And so you'll find a lot of Caesar cipher programs out on the internet that do it that way, right? If it's a letter, you apply a conversion to it. If it's a non-letter, if it's punctuation, you leave it alone. But we are so awesome that we're going to apply the shift to absolutely everything using its ASCII value. So that if you're sitting there on a lowercase v and you added 5 to it, it would become a 1, 2, 3, 4, 5. It'd become a curly brace, right? And then when you shifted it backwards, if you saw a closed curly brace and you subtracted 7 from it because you asked it to shift 7, then that would be 1, 2, 3, 4, 5, 6, 7. And so that curly brace is really supposed to be a V. It's a cool little project, and lots of people like this one. All you do is you need to store, most likely, your string into an array, but you don't even need to do that. You just need to step through the string character by character, shifting them up or down as requested. And if you get stuck on it, I can help you with pseudocode or flowchart on that one. I'll do that on any of these if you get stuck. Just ask me for help. So we good? We done talking about projects and arrays? I think so. Alrighty.